One of my favorite features from real-time intelligence in Fabric is the update policies. This gives me opportunity to load data really fast between tables in the KQL database. Think of it as a trigger for your ingestion data. This automatically transforms and moves the data in your database. This could be for implementation of a medallion architecture in real-time intelligence. So today I will show you how to build an update policy and get my data moving fast between the tables. This feature also works in Azure Data Explorer, but I will use Microsoft Fabric. I'm going to build an update policy as a part of a medallion architecture in real-time intelligence. The sky's the limit here. You don't need to use only one table. You can do whatever you need. You can do data transformations, you can do lookups, you can do cleaning, you can also do calculations, whatever you need to get your data on the run. I'll show you how to get started and talk about the different possibilities we have with the update policies. Here I am in Fabric, and I have quickly set up a small demo workspace to show you these update policies. First of all, I have set up an event stream which streams data from the bicycle demo dataset provided by Microsoft. The setup is quite simple. I've selected the bicycle demo data. You can see a snapshot of the data right here. And then I've just directly inputted it or streamed it to my demo data set inside a KQL database. And that KQL database is this one based in this event house named Brian's Event House. The KQL database is this one, and in this database I have this table called bicycle demo. Right now it has 784 rows inserted, and it is streaming right now, so you can see today, this minute, the last record has been streamed. And I have also created an empty KQL query set. This empty KQL query set connects to my KQL database, and here you can see my bicycle demo table. The table consists of these columns, and if I run a query where I just take the top 100, you can see the example dataset right here. So let us set up an update policy on this table, but first of all I need to alter it because for this demo, I would like to show you the ingestion time. So for every table in a KQL database, I can alter the table policy, and then I can enable the ingestion time equals to true. Now I've executed this, and now the table has an unhidden column named ingestion time equals to true. If I refresh this page, you might be able to see it already. Bicycle demo. It is not present there, but I can show you that it is actually there. So if I extend the ingestion time, then you can see I now have a column with a small dollar sign at the beginning, showing me when this row was ingested. Now I can use this column to try to do some calculations. So I would love for my next table of the update policy to have a calculation. Any update policy can have any query attached to it. The update policy, as I said in the beginning, moves data quite fast from the source to the destination, and I can do all sorts of calculations with it. So in order to demo that, I will add the total number of bikes equals to number of empty docks plus number of bikes. This now gives me a new column named total number of bikes, and I would also like to extend one more. I could put the extend up here, of course, but for this demo, I will show you that I would love to have the ingestion time equals to ingestion time. And I only want for this specific update policy, I only want the neighborhood to be equal to, let me see, what do we have? This one. Notice that I put the where clause at the beginning. If you want to optimize your KQL query set, then if a column is present at the preceding row, so that is the first row here, I have all columns present, and I want to filter something, then please do it as early as possible, because then you help the engine to optimize way faster. If I execute this, you will see I only get bicycles or the bike points ID from the neighborhood of Wandsworth Road, and I have the ingestion time and the total number of bikes. All I need to do now is to create a function. I'll call this load bicycles to silver. And there you go. Now I have a function that just execute a KQL statement. This function I can attach to an update policy. But before I attach it to an update policy, I need to create the destination table for me. So create table bicycle data silver, if I could spell, sorry for that one. And then just add my columns, bike and there you go. I now have created my create table statement, and I can execute it, and instantly you will see that I have this new table called bicycle data silver. I've been very cautious to map the columns in the right order and in the right format to match the select statement that we just created. Now we can create the update policy, and the update policy is always attached to the destination table. So I like to alter the destination table called bicycle data silver, and the policy should be update. This accepts a JSON object as the parameter, so I'll just quickly create that one. And in order to break it down for you, I'll write it in several lines, but when we execute it, I'll put it into one line. The first one is that we need this update policy to be enabled. Is enabled. That must be true. The next thing we want is the source. The source is the source table. So this update policy will listen to the source table, this one, the bicycle demo. Every time a record enters this table, this update policy will execute. So the source is the bicycle demo, that's the table. Oops. The next one is the query. What should the update policy do with the records entering this table? Then it should execute the query that we just created. This query is the function load policy load bicycles to silver. I'll put that in there. And next one, I want this to be transactional. Is transactional equals true. Is transactional means that every time a row enters or loads with this update policy from the source to the destination table, it will load as one transaction. Even though it is 2, 3 or more rows, it will load as one transaction. If one of those rows fails in the load, then the entire transaction will fail. So if you have 3 rows entering the source table and should be loaded to the destination table, and one of them fails in that process, then the entire transaction will fail. Not even one row will enter this table. If I set this to false, then the existing rows that has entered the destination table will stay there, and the rest of the rows will be discarded. The last thing I need to add is this one. I have a longer explanation in my blog post on how this works and how you should put it there. And as I said before, I need to put this in one line of text. Now I can execute this update policy and add it to the destination table called bicycle data silver. I also want for this demo to show you how fast it actually adds the rows. So I will just add the bicycle data silver policy ingestion time to true. So now I have both policy ingestion time on bicycle demo and bicycle data silver. When I've added the policy of ingestion time to true, I can now begin to show you that the bicycle data silver table should begin to accept data now. There you go. The bicycle data silver now has 3 rows after the update policy has been added, and you can see the ingestion time. This ingestion time is the date time for the for the ingestion to the bicycle demo. So these rows has been added to the bicycle demo at this date time set. So I need to add the ingestion time. Then I can show you that this is the first enter into the destination table called bicycle demo, and this is the date time for this same row entering the silver table. If I want to calculate the difference between these two, I can just add this to a time from raw to silver, which is a date time, if I could spell, date time diff in milliseconds. It helped me there. Milli, 2 L's in millisecond between the ingestion time and the ingestion time column, which is in a capital I. And let me remove that one. Execute. Now you can see that it only takes 76 or 79 milliseconds from the row entering the bicycle table till it is present in the bicycle data silver. This is quite fast. And there you go. An update policy created on one table to load data from another table, and within a few milliseconds I have data in my destination table that I can use for further analysis and reporting. I hope you like this, and if you need any help or questions, just reach out to me on LinkedIn or here on YouTube, and I'll gladly help you. And until next time, happy coding.